Welcome to the session. My name is Majano. I'm the CEO of Orchard Solutions. I am a computer engineer by trade. My specialty was embedded systems or microchip design. I was born in El Salvador in Central America. I was raised here in the US, and I'm on loan to Spain for the moment. I'm leading the charge of the EU expansion for Ortis, so I'll be there for a few years. I'm the creator and maintainer still of many frameworks, from MVC to content management systems to testing frameworks, and I am one of the chief language engineers for BoxLang programming language. I always like to start with a dad joke. My kids love it. So what do you call an anxious dinosaur? No takers? A nervous Rex. There you go. I satisfy my kids now with my dad joke. All right, so we're gonna have a few points to discuss. What is BoxLang? Why did we create a new programming language? A little bit of a discussion on this. The goals that we had, the semantics, so what is different than other languages, and then of course our feature set and how you can start. We are on release candidate. This is gonna be released in a few months in Washington, DC, in our own conference. There's publish the slides so you guys can get more discounts and see where to go for our conference. All right, so we'll start with BoxLang. So what is BoxLang? It's a new modular dynamic language for the JVM. Our aim is to make you more productive, expressive, and functional, and available everywhere. And that sentence is basically everything that we wanted when we began this project. It is dynamically typed with an optional and inferred coercion type system. Supports, of course, classes, but it also supports scripting and templating. Using modern Java interop, it uses invoke dynamic within the hood. We've actually created an entire framework around it. Highly functional, from context-aware closures to pure lambdas and more. But it is not only a language, but it's also a built-in framework. And we'll discuss a little bit about that. It is small and lightweight. The entire engine is 8 megabytes. We open sourced it last year in our conference. We've done about 30 releases already. Release candidate 2 was yesterday, and our final release is coming in a few months here. So even at the booth, a lot of people have asked, okay, why create a new language, right? Important question. But before we start with the why, I want to start with who we are, because that basically gives you an insight of the why. So the name of the company pushing the language is called Orchard Solutions. We're a professional open source company. It started in 2006, so we've been around for almost 20 years, so we're not new. We are a set of polyglot developers within Ortus, everybody with different skills and different languages, from Java to Rust to Python to Scala to CFML to Node.js, etc. And we've created the majority of frameworks for the CFML ecosystem, like I mentioned before, and we manage over 350 open source libraries. So 19 plus years of really serving the open source community, and we create tools and these custom solutions. So with that background, it came to basically, okay, why did you create it, right? We didn't obviously wake up one day and say, I want to create a language. We're a little crazy, not that crazy. But it was really more of the culmination of all those 19 years of software development. It was the last piece for us. We really felt we couldn't continue to innovate in the current language set. We needed a way forward for us as developers at Ortus and for our clients and community. And there really has not been a lot of movement in the dynamic languages space in the JVM. The last, I would say, major release of a language was about 12 years ago. So we really wanted to focus on a language of the times. And I go really in depth into why and all the decisions that we made internally on why this became about, and you can read it there as well. With that came goals and visions, because we started from scratch. We were like, okay, a software language has to be designed today. How would that work, right? And that's what we focused on. And we said, okay, it has to be highly dynamic. Obviously, we come from like dynamic languages. Modular. We've created modular and hierarchical MVC frameworks. Lightweight and fast. Be 100% interoperable with Java, so from day zero, the entire Java ecosystem is available. Be modern and functional and fluent. We've been working with all of these languages, and this is really makes you very productive, and it helps you when you read code when it's functional instead of the traditional imperative coding. Modularity at its core, important for us. Taking advantage of the modern JVM. It's not the same as 10 years ago. Fully tested. This was super important for us since we've built already testing frameworks. It had to be there. Be able to support multiple runtimes or deploy where another runtime doesn't even exist now. AST focused. We wanted to create lots of tools. Specifically, if you have done dynamic languages before, the tooling was not great. And multiple transpilers. We had so much history that we wanted to bring over. And I'll discuss a little bit about it. And of course, to integrate with other languages easily. So it not only integrates with Java, but with other languages too. So I'll start off with high-level key features and move down into semantics. The first kind of high-level feature is multi-runtime architecture. I believe this is what really made Kotlin very famous, is the ability to do that. However, we started a little bit different. We started at the operating system level, at the lowest possible level, which are microchips. The lowest possible JVM available, that's where we focused. And our entire language is 8 megabytes. It is extremely small, extremely lightweight. And then we started creating all the different runtimes that are available to you, from Docker containers to our own mini server, which is a super lightweight Java server. CommandBox. CommandBox has been a servlet engine that we've built for more than 15 years now. It's analogous to a Tomcat. Of course, the servlet, so you can deploy to any servlet. Lambdas, so you can deploy to Lambdas. Azure functions, Google functions, and we are still working on Android and WebAssembly. Lambdas was an interesting one. This is something that we have been requested for so long, and we really needed to go there very easily. And we ended up building our first production application called try.boxlang.io. So if you actually want to go there and try it out on your phone, you can. What it is, it's 2 microservices. It is one using the mini server cloud container, super lightweight, super small, 128 megabytes of RAM. And that's the entire UI for the microservice. And then everything is there for you to type your code, which is BoxLang code. It's sent to AWS Lambdas. It is processed by a Lambda runtime that we've created as well. And then it will execute that BoxLang source in this specific Lambda for you, and then return the results to you. So this is basically a way for you to test BoxLang with BoxLang. So you can go to it now. It's in try.boxlang.io. Like I said, try it out. And this was our first production application powered by those 2 microservices. Actually, it's using our templating language that I'll show you a little bit about with Alpine.js to do binding, and of course, our Lambda runtimes. So a lot of things and a lot of focus has been put in serverless as well. All right, another big feature is how does a modern dynamic language look like today, not 10, 12 years ago? Well, obviously, dynamically typed, but we also made it optional typing for those that are coming from a statically typed approach. JSR 223 compliant. This means that if you already have Java applications, you can very easily bring in the scripting capabilities of BoxLang into your Java applications. No reflection. We use invoke dynamic for everything. We created our own framework called dynamic object, which basically allows any class to become dynamic in BoxLang. Even if it's statically typed, it can have pseudo-dynamic aspects to it at runtime, from type promotions to auto-boxing, auto-casting, and coercions. Of course, it supports all the common OO constructs that you're used to coming from Java. And of course, we try to leverage all the new JDK features starting from JDK 21. So JDK 21 is the base for BoxLang. This was another big goal for us, is we wanted to create the architecture when we designed the parser to be multi-parser architecture. All pivoting on what we call the BLAST, which is the BoxLang AST, or the abstract syntax tree. And this was really a way for us to split the old and bring the new. We had worked for more than 20 years bringing legacy applications to life. So this was a great way to bring legacy applications to life. It has a just-in-time transpiler and also a CLI transpiler. And we now have several languages that we support. For example, ColdFusion and CFML. If you have an application that's built on that, it can actually transpile and run in our runtime natively. We're working on COBOL, for all clients that have old code. They can not even touch the code, and it will run in the BoxLang runtime. We're planning on Groovy coming soon, and actually there was another request for Java itself. So there have been a request that you can actually type in Java, and it will transpile it in BoxLang to make it less boilerplate. So this was very important for us in order to bring even more ecosystems and be able to provide a single set of tooling for anybody that has old code or old languages and be able to bring them over into BoxLang, into the BoxLang AST. The Java interop was an incredible goal for us to make sure that Java developers came and acted naturally. So as you can see, you do the same things. You have imports. We've created aliases for imports as well. You can actually import from BoxLang classes or Java classes. We also have the concept of prefixes, so you can actually create your own resolvers and actually define how classes are resolved inside of BoxLang. And like I said, we'll take care of all the type promotions, all the contagious approaches for numerics as well. So all the things that you're used to are available and more, just to try to make things easy. For example, from a dynamic class, you can extend a static class. Like here, I can have a class that implements runnable, but you can also use extends. Here's an extends version. You just say, hey, I want to extend from Java timer task, right? So we try to make it really, really simple if somebody comes from Java to be able to integrate and work. With all that, that basically takes us to a few semantics. Now, the majority of languages nowadays are all kind of similar, so I'm only going to discuss a few things that are different. The majority of things are always similar in every language. We have three types of executions in BoxLang. We have the ability to do classes, like in Java, but we also have the ability to do scripts, which are BXS files, and we can also do native templating for building UIs, and that's using a BXM file. So we have those three files supported. Major differences between Java: scopes. We have the concept of scopes for all variables. So every variable that you define, depending on the context where you write it, will be stored inside of a scope. And these scopes are backed by concurrent maps, and they're all case insensitive to make it easier for you. Okay? You can also choose case sensitivity if you want. But each execution context have different scopes. For example, scripts has variable scopes, functions have argument scopes and local scopes to the function specific or the surrounding scope access, right? Classes have access to the disk scope like in Java, variable scope, and of course static. Then we also have the concept of threads as well, as probably we'll see a little bit, and it has other concept of scopes, right? And then we have the concept of global scopes. And global scopes basically give you the ability to create storage. So if I want to create a singleton, I don't have to create a singleton pattern inside of my class. I just dump it inside of the application scope, and I have a singleton available. If I wanted to create one for the request, if I'm in a web application, I can dump it into the request scope. I have a server scope, I have a session scope, and depending on where you are deploying your runtime, you get more scopes available to you. And then you can also build your own scopes if you wanted to. The cool thing about scopes is that you can treat them functionally. So here I'm actually basically looking at a variable scope and filtering by a specific lambda in this case. So there are many things that you can do with these scopes, and you can even pass them around. And that's really cool that you cannot do, for example, in Java. We've also have enhanced types and member methods. So this means that you get all the gamut of, or plethora of types that you have in Java, but we have enhanced types. We have our own versions of arrays that are very simple to use, and you can have array literals defined everywhere, as you can see defined here with member methods for those array literals. You can do structs, which, like I said, are basically case-insensitive maps. You can have them ordered, unordered, weak, soft, just like in Java, very easily. We have the concept of queries. So queries that can have typed columns or untyped columns very easily when you interact with JDBC. We have our own version of datetime, so it can comply to JSON serializations or YAML serializations. We have the concept of numerics as well, and this is something that is inferred. Okay, so all the types are contagious. That means that if you start with a computation in an integer and it's going to become a very big computation, we'll automatically convert it to a big decimal. So all those big decimal computations can be done behind the scenes without you interacting with all those big decimal classes. Again, making you productive. And of course, we even have an XML native class that is treated like a structure. So you can navigate XML using structs. They're all auto-castable, they're all dynamic, and they're all functional. So here, for example, that array, I can append things functionally, I can filter them, I can iterate, and everything is native to JSON. So I can just say to JSON on any type, and it will be converted to JSON. Here's, for example, I'm adding a closure into a struct to simulate, for example, a class. So it's kind of like a record, right? And then I can have person.fullname and actually execute the closure that I just basically dynamically injected into that map. Very different. Functions are a little bit different, okay? All functions are public by default. All return types are any by default. All arguments are any by default. And the question is, what is any? Well, any can be anything, okay? It can be either at compile time or it can be inferred at runtime, okay? And you have a choice whether you want to go full dynamic and not define anything, or you can be optionally generic. So you can say, okay, this has the potential to be a number, or you can become very specific and say, no, it's gonna be an int. And we'll take care of the casting, we'll take care of the promotions, everything for you. So it makes it really easy for you to be productive in that sense. Now, these function arguments, there's more to them. You can also define when they're required with the required annotation. So you can say required string, for example. Default values, these are really something that Java hopefully can bring one day, but we've had them for a lot of times. So you can have default values. You can also have default value bindings. So depending on the context of the function, you can bind to a variable scope, to a static scope, etc. So you can reach out of your class even if you wanted to. Another important thing is that we also have the concept of argument binding. So since all the scopes are maps, I can basically execute any function and say, all the arguments, just bind them from this map. So I can use the keyword argument collection. And then it will look at that map or an array, and it will try to match them according to what you have. So very, very simple. You can do things very dynamically. Now, for function variables, you don't need to var functions. Just like in Java, you have var or you have to define the type. You don't have to. You can if you wanted to, but you don't have to. They're all inferred. Okay? You can mix types if you want, or you can make them strict. You can do struct and array literals. You also have an ordered struct literal, as you can see there, for ordered map. Okay? And of course, if you declare them to be final, then of course you can't reassign them. But it gives you the flexibility out of the box. Null coalescence operators and safe navigation operators are something that are really productive for you when you're building applications. If not, you have to do lots of if statements and checks. The Elvis operator, basically anything on the left-hand side of the Elvis operator, it treats the entire expression. If it's null, then it uses the right-hand side. And the right-hand side can also be an expression. Right? The safe navigation is really useful, especially for the day of APIs. When you're navigating JSON structures, for example, or XML structures, you can just use the period and the question mark, and then navigate throughout it safely. And then, of course, you can combine it even with Elvis as well if you wanted to. Like there, and like here. Since we're in a dynamic language, obviously you can do reassignments. That's one of the flexibilities around it. So you can change values and types. However, you can mark them as final as well. You have the final modifier as well. And then, of course, you can't change the type of that specific assignment. You can mutate it, but it won't be changing your assignment. Variable casting, this is done automatically for you, but if you want to be explicit, you can use our cast as operator. So you don't have to be dealing with parentheses or outer parentheses or an inner and an outer parentheses like we do in Java to actually cast something. You can basically just have an expression cast as and then another expression. So it doesn't even have to be the specific type. It can actually be a dynamic expression that builds the name of a specific type. Very fluent, very easy to read, for cast as long. We have the concept of unmodifiable variables as well. So we have member methods called toUnmodifiable and toModifiable as well. It can apply to any array list or any list, any query or any struct or native Java types as well. So you can very easily create an array, say to unmodifiable, and pass it around, and then it's unmodifiable. String interpolation is super easy. It allows you to basically do any expression inside of a hash. Okay? This is inspired obviously by a lot of front-end frameworks. You basically have a hash expression and anything inside of it will be evaluated for you. You also have the ability to declare big strings. Java introduced that in JDK 17, I believe, the 3 quotes. For us, it can be a single quote or it can be a double quote. It doesn't really matter. And then whatever's inside of it will respect with or without line breaks. So you can just go ahead and create your big strings and we'll respect it as you write them, even with interpolation inside. We have the concept of closures and lambdas in BoxLang. So context-aware closures are using the fed arrow, and this basically means that the actual function has knowledge of where it's defined or its birthplace. And then pure functions or lambdas have no concept of their outside world. These are faster and they're deterministic. Whatever comes in, it's supposed to determine the output of that execution. So they're pure. They're not supposed to be doing any side effects from its outside context. Okay? We also do automatic coercions. So if you're interacting with a Java library that requires lambdas and specific functional interfaces, we'll take care of that from BoxLang. Even if it's anything, really, we've actually done every single functional interface in the JDK or in your own applications. It will look at them and it will convert or BoxLang closures or lambdas to adhere to those functional interfaces. And the cool thing is that you can also pass all these functions around just like objects. So you can define a closure or define a lambda and pass it around just like any other object. We've done a lot of work on classes to make them really dynamic, but also really productive. There's automatic constructors on the classes, automatic toString, equals, and hash codes, automatic getters and setters for all the properties that you define. Okay? Automatic invoke implicit actions as well, so you don't even have to call a getter. You can actually just say, for example, in this case, person.firstName, and we will discover that it has a getter and call the getter for you. So less boilerplate for you. But it's also first-class citizen for JSON and YAML. So we can look at any class and it can be converted to JSON. It will look at all those properties and it will basically build a JSON representation of your class without you doing basically anything. You can actually customize it. You can actually choose JSON includes, JSON excludes, what will be available, what will not be available. So you can get very customized in the way that you represent your classes as JSON or YAML. This was huge for us in a dynamic language. We have the concept of meta-programming. Every class, whether it's BoxLang or Java, has a $BX object attached to it. And you can talk to it just by dereference it, like person.$BX, and you have many things available to you. You have meta, which is basically metadata about your class. How many properties, how many functions, where is it located, how it was loaded, the class loader that loaded it. You have the $class, so you actually have which class representation it does. But you also have meta methods. You can actually do change listeners. So imagine if you wanted to register a change listener, like here on the variable scope, that every time there is a change on that scope, I want to listen to it. You can very easily do that. So you can create listeners for any map, for any query, for any array, for any object. Okay? You can remove properties, you can inject properties, you can inject methods, you can remove methods, etc. So as a framework developer, if you're a library developer or you're wanting to do things dynamically at runtime, you can do it very easily with this API. We've done lots of UIs throughout the whole process and built tons of frameworks for the UI, and we brought all that knowledge into our templating language. So this has been inspired by Blade, by JSP, CoFusion, GSP, and this has become our BX templating language, and also extensible. So you can create your own basically tags very easily. You can import collections of tags, for example. You can use headlets functions. You can do nesting, data encapsulation. The idea is to make you productive when you're building UIs with a nice templating language. And if you actually just wanted to use the templating language in a Java application, you can very easily. And with that, we took it further. So if you're actually writing, for example, an email service, and you actually needed some templating, we have the concept of tag islands. So you can actually just create the 3 little bars, the 3 little quotes, and that becomes now a template area. So here, for example, I'm inside binding a collection, and I can say, the 3 little quotes, and then I basically now move into the templating language, create a nice little template, and then I can return it. So you have all these capabilities to be able to do UIs and templating very easily, instead of doing it manually. All right, those are the majority of differences there's much more, but these are a few that you can focus on in terms of semantics for the language. However, like I mentioned before, BoxLang is not only a language, but we brought in all the different history of all the different frameworks and libraries that we built in order to create the BoxLang runtime. And the BoxLang runtime is composed of many different services, from an application service that I will take you through, an asynchronous service, so we have all kinds of asynchronous and parallel computation capabilities, a caching service available already inside of the language, a component service, which was basically to create different components that don't need any type of parsing. So you can extend the language as developers. Data source services, so we completely manage all of your data sources to any type of JDBC connector, and we have a complete framework just for querying, doing transaction demarcations, and transactioning for you. Functions as well, so you can register global functions or headless functions, and interceptor service, which is the entire language is event-driven, or module service to create the different modularity aspects of the language so we can extend the language, and a scheduler to allow you to do scheduled tasks or periodical tasks or even queues just right out of the box inside of the language. So we'll go through a few of them. The enterprise caching engine and aggregator is something that we had created a long time ago, and we ported it over when we created the language. This is a nice little design of what it includes. We have our own enterprise cache engine, okay, that's available to you with the different types of storages, from concurrent maps to software reference maps to disk to JDBC or custom ones. But it's also extensible. You can create your own custom providers, your custom object stores, and it also is event-driven. You can get announced when something is removed from the cache, updated from the cache, added from the cache. It has an entire system for statistics, and it powers really all the internal caching inside of the language itself. So you even have access to all of these caches, and you can define them in configuration or at runtime. We also created the concept of an application framework for you when you're building applications, whether this is from the CLI or from web applications. And this example here is, for example, the runtime for a web root, and you can have many sub-applications using a single file called application.bx. So this is inspired by Java context. And this gives you basically an infinite segregated application deployment strategy within your same app, and each application.bx has different life cycles. It's a single class that allows you to listen when the application starts, when a new session starts, when a session ends from a user, when there's a new request, when there's a request end. So all of these listeners are available to you when building applications. You don't have to do this anymore manually. You have all these interception points that you have access to. And all these applications inherit from the global configuration of the language, but then they can have subsets and overrides. So for example, in sub-application A, I just want these data sources, or this AI configuration, or this type of application scope. So you can define and pick and choose, and you can create this nice tree of applications with one deployment. The other one that is really important for us as developers is scheduling and tasks. And this is available to you out of the box. You have the capability to create what we call schedulers. And they are portable classes. They are fluent and they are human. They're completely readable. You can write them in BoxLang or you can write them in Java. They basically leverage the completable futures API in the JDK. You have the ability to declare different executors, even virtual threads if you wanted to. And you can even schedule them at the operating system. You don't even need, for example, cron. You can just say BoxLang schedule and the name of your scheduler class, and that's it. It will actually spin up your scheduler. It will start processing and working and block until you kill the scheduler. So it gives you a nice way for you to actually build all these things. We have a lot of things coming for this in our premium version for a task visualizer, so you can visualize all the tasks that are running at one specific time, pause them, stop them, restart them, get data, etc. And all of this is possible because the language itself is event-driven. And this was extremely important for us. We wanted to make sure that the entire language could be extended at any point in time. So we added events that are being announced throughout different lifecycle processes. Like you just saw with an application, on request start, on request end, when there's an exception, when a class is compiled, when a class is instantiated, when a method is being invoked. So imagine if you actually wanted to add AOP, you don't even have to use Spring AOP. You can basically just create a listener that listens to a class invocation and then basically decide what you do with it. Okay, very, very easily. That's what we wanted, for you to be productive. You can also create your own custom events. And that was also important for us as developers, is that, okay, great, you have, over 100 events from the language itself, but what if you wanted events, right? So you have the capability to register your own interception points. So on order save, pre-custom order, on user login, on user logout, okay? And then you can have different global bits that can say, okay, box announce, okay? Or box announce a sync, and you get a completable future. So you have the entire approach of event-driven language available to you for your own applications as well. The next one was modularity. The language and the core was so tiny that we needed a way to extend according to your needs. So we designed the modular service based or inspired by the work that we had done in our frameworks, building a hierarchical MVC framework. So this is not OSGI. This is built from scratch and lightweight, and it allows you to create hierarchical class loaders. So it gives you isolation. If you actually wanted to create a module that uses a version, very old version of Apache Commons, you can. But then another module that uses the newest version of Apache Commons, you are okay. So there will be no class loading hell, basically. You will have complete isolation, and you can move them around as you see fit. They also tap into the language lifecycle. So all these modules, by default, can listen to all kinds of events. You can write them in Java, you can write them in BoxLang, or you can write them in both. Okay? They can also extend the CLI. So you can build CLI applications with modules as well. So every module has an entry point that comes from the CLI, and you can create CLI applications with it as well. It integrates with Maven and Grateful dependencies very easily as well. We provide a template for users so they can actually create very easily your modules. And we have created tons of these now. We have over 40 modules that we've developed. And this is what brings the power into the language. From FTP tooling and SFTP tooling, email sending capabilities, ESAPI, UI forms, password encryptions, JDBC drivers, image manipulation, PDF tooling, spreadsheet and CSV manipulation, low level like Py4j and OSHI for operating system and hardware information. And yesterday we published our AI module, so now you can integrate with any AI provider as well very easily. And of course, we will have also premium modules if you're a subscriber as well to our premium version. It is very easy. Here's a little snippet of how actually you're creating a global function. You basically create a class with annotations that are very similar to Java. And then you have an invoke function with the different arguments. You can use the default arguments. Whoa. There you go. The default arguments if you wanted to. And very easily in BoxLang, you can create your own global functions for your language, because now it becomes your language. Okay? To see an example of tons of these, my crazy friend with the green hat there, you can ask him questions, built this module called BX Waffle. And it has basically all kinds of capabilities to extend the language, just to give you an example. Okay? So BoxLang is modular by design, and that was very important for us. We manage a modular ecosystem called ForgeBox, very similar to Maven Central. It's called ForgeBox.io, and this is going to be exclusive for BoxLang modules. So you can write your own functions, your own schedulers, your own JDBC drivers if you wanted to, etc. And this is basically the way to encourage third-party vendors or you as developers to share and build a community. And what's also important is that we're actually right now building the e-commerce platform for ForgeBox. And this was important, so if a developer wants to sell a module or wants to sell some type of capability, you can sign up in ForgeBox, you can choose your license, you can choose how you want to get paid, and we'll actually take care of everything for you. So it'll be a full-blown store for all your information as well. And this is actually what we're going to be using for our premium modules as well. But that also gave us the capability to do more. So for example, we've integrated the Python language into BoxLang via modules by using JSR 223 compliancy. And we've created the BX-Jython. We're actually working on 3 more using some of the Growl VMs providers through their Truffle framework. They're in development. There's one for Python, there's one for Ruby, and I think there's another one for Groovy, actually. And they will be available to you, so you can just say install BX-Jython, and you can actually have a nice component that says Jython, and then open squiggly mark, and you can basically code in Python, and we'll create the bindings between the 2 languages for you. Okay? You can instantiate Python classes in this case, and use them very easily. And that's the idea for us, is we wanted to make sure that BoxLang could integrate with all the things that we have developed on without running them in other approaches. Tooling was critical for us, especially for a dynamic language. Static languages are amazing because everything is defined at compile time, right? So you have that access and that capability, and you can build great tools around the static language. Tooling was very important for us. We have 2 sets of tools that we've developed and are continue to develop, one based on Visual Studio Code, the other one at the CLI level. We still have plans for IntelliJ, but it's not there yet, so I'm showing you what exists now. And then we can talk about what's coming. So for Visual Studio Code, the BoxLang IDE is available already. We have our own language debugger and LSP, and the language server protocol is actually built also with BoxLang. So it's another runtime that we've addressed on itself. It has the ability for you to execute classes with a main function already, run scripts, manage and run specific mini servers, code converters, code formatters, code quality, visualizers. So we're adding all kinds of tooling into the IDE for you, specifics to a dynamic language. We also have a lot of CLI toolings, from a built-in REPL to the ability to execute shebang scripts from the scripting side of it, ability to run files, ability to run the schedulers, the transpiler, so you can actually tap into the transpiler immediately, and also the compiler, so you can actually do compilation as well. We have actual feature audits, so you can actually learn how to build feature audits for your projects. And of course, we're working on a packager to really compile and package your modules or BoxLang applications right from the CLI and the IDE. So all these tools were very important for us. Just try them out and give us your feedback. And of course, we've gotten huge feedbacks for IntelliJ, so that is going to be coming soon. Almost done. This was really important for us, is that the entire language be tested and documented. We are big on this, creating professional open source for a long time now. So we have a collection of over 6,300 tests already, actually more tests than commits at this point. Not only in Java, but using BoxLang, we've actually integrated the ability for you to execute within JUnit all the BoxLang code as well. We have our own testing framework called TestBox, which is actually even included as well to give you types of behavioral-driven development as well. Native assertions into the language as well, and completely documented from all the API docs to a book. So we already wrote the book for it, which is in process, called boxlang.ortusbooks.com. It is free online. Everything will be documented there. And once we finish and go gold, then that book moves to Amazon as well, so you can have it as print available. So a lot of work has been put in. It's only been actually less than a year since we announced it. So we're moving very, very, very quickly and very fast, and need lots of feedback from the community. So if you want to get started, just head over to our books and start trying it out for scripting, for integrations, and how can we be of assistance to get this language available to more folks as well. So with that, I'll open to questions. We only have a few more minutes.
So the AWS lab and the runs on Java.
Say that again?
The lab, the AWS lab, it runs on Java.
Yes, on the Java runtime. Yes, and you can see, for example, let me see if I can put it here. Let me mirror now. So on the docs, you'll see here running BoxLang. So you'll see all the different runtimes. As we start adding more runtimes, you're just going to start seeing more code here. So Lambda, we actually have everything completely documented. We even have our own Lambda template. So you can actually go to GitHub. For example, AWS Lambda template, I believe it's called. No. Let me show you here. AWS Lambda template. So we have a full template that you can go and say, okay, I want to create a serverless application to say, create a new repository with this template. And it will basically have all the dependencies for you. You just code your serverless. It even has automatic deployment to AWS. Just put in your credentials as secrets, and it'll even build a staging environment for you and a production environment for you. So we've done all that for you, so you can very, very quickly get up and started with it. And this is based on Lambdas. So this is a code editor that we've done online. So you can run here, and this is executing on the Lambdas, as you can see, right? Right here, the evaluation. If we want to remove it, you can see the buffer here and all that. You can copy links here and share them. You can embed the code if you wanted to. So if you want to embed the code, you have all kinds of commands available to you as well. So it's a subset of our IDE online as well. And this was built with those two microservices. Okay. So lots of effort in getting all those different things. If you already have a Java application, you can use our JavaScripting ability basically to tap into BoxLang, and then you can very easily interact with it as well. Yeah?
I have a question. So you had talked earlier about concurrent maps, and
yes.
how the scope of variables are all defined within concurrent maps.
Yes.
Is there any issues when, say, doing something multi-threaded and accessing said variables in that same scope? So if I access two variables from two different threads that are located in the same scope, if they're both in the same concurrent map, would that not have issues?
Well, the concurrent maps are specifically for threading, so that will help you there, right? So
encounter like a lock scenario where
you could, and I think that would be a problem in any approach that you use, for example. But you could potentially put inside like an atomic object inside of the actual concurrent map as well. So imagine you could put an atomic long or atomic boolean or atomic integer. Dealing with threads is not easy. It's a pain, and especially with concurrency. So I would say that depending on what you're doing, you can leverage the concurrent map differently, per se. So, but yes, I'm with you, especially when you deal with concurrency. Yes, but we also have a thread scope as well. And that's specifically for creating inline threads, like a block of code. And then you can create a thread inside of it that's safe for you. And then you can basically, it creates a bridge for you between the two things. It's already documented here, but we've done a lot of work to make it easier when you're doing concurrency, if possible. But yeah, it's a pain. Good question.
ETA on the JetBrains IDE integration?
No, that's the IDE man right there. So he's the one that built the IDE. So we need to pester him and give him lots of coffee and pastries, and hopefully we'll have that soon. Yes?
What is this BLAST parser that you mentioned?
Sure. So the BLAST is the AST tree. So that means that when a file is parsed, we use Antler, by the way. So yes, we're using Antler. So it parses the file to our parse tree, and then our parse tree becomes our AST representation, right? What we wanted is that we had so much history with other languages that we wanted to bring in easily. So we don't go from the parse tree to bytecode immediately. We go from the parse tree to the AST, so then from the AST we go to bytecode. So what this next step allowed us is to bring, for example, Cold Fusion code, parse it, and bring it to our AST, and then convert it to bytecode. And now we have, without touching Cold Fusion code, it will run in a runtime as natively. It actually runs faster than Adobe Cold Fusion in our runtime than in the actual language vendor.
Okay.
Yes.
Is that available as a separate library, this BLAST?
It's part of the core right now. And you can see all the examples, and you can talk to these gentlemen if you have more questions about that one. But it's part of the core, and the two parsing grammars are there. But the idea is to make that modular. So, for example, we have a client that might be onboarded with the COBOL parser, for example. And that might be a module that goes through the lifecycle and that will incorporate the ability to parse COBOL files execute them in our runtime. So it opens a lot of possibilities that were not possible before, basically. Yeah. So the parser might not be the fastest in the world, but that's on purpose, right? It's not meant to go from parsing to bytecode directly. It goes from parse tree to our AST, which is our commonality, and then we can decide how to do things. Other questions?
Make waffles.
It did, the X-Waffle. Any curiosities? Sure.
Code generation, can you do that? You say you're tying into Graal.
We will be tying into Graal later for all the different languages that they built using their truffle framework. So we want to build a few subset of modules of those so you can integrate them. But are you talking just code generation?
Yeah, so you can target WebAssembly, native code for what? For iOS, for Android, for Linux, for Mac OS.
Correct. So, well, the idea with the runtime is that it will do that for you, right? So right now, we're going to work on the WebAssembly portions and on the runtime, for example. But are you talking about taking a piece of code?
Code that does not require the JVM.
Ah, okay, got you. I understand you. Correct. I understand you. No, we haven't looked at that yet, but I think it might be on our horizon. Yeah. Yes?
How does the Java interrupt compare to Kotlin's Java interrupt?
Compared to what?
Kotlin's Java interrupt.
Okay. It's very similar. Now remember, Kotlin is a static language. It is not a dynamic language, right? So Kotlin only does inference. It doesn't do type coercion. So we do a lot of type coercion, and we do, for example, contagious numerics. So that means that if you have an int, it can contagiously move across the line, right? Depending on the computation that you're working with, right? So Kotlin has a subset, and we have an expanded subset from Kotlin.
How do you do? But you said you can call BoxLang from Java.
Yes, you can.
How does that?
Well, if you're in Java, right, and you include the BoxLang jar, it just becomes another library, and then you can basically execute it statically, so it won't be dynamic at that point, right? The library, right? But let's say you wanted to execute a template, right? You would say BoxLang runner dot execute template, and then you would pass in a BoxLang template, right?
Using it from Java, does it feel like you're using Java?
Yes. When you're interacting with the library. But if you're building BoxLang classes or BoxLang templates, then it's BoxLang. Okay. An example, if you want to use the cache engine, right? You can use the cache engine just from BoxLang as your own cache engine. And then it will be used as a Java library. So you can include the BoxLang jar, and you can instantiate our cache, and it's like a Java cache at that point.
It's not like using Ruby or Scala.
No. The majority of BoxLang is written in Java. Yeah. So you will feel right at home.
If you're using BoxLang as a library, you get all those internal events.
Yes, if you actually execute, if you use specific execution entry points, then yes. If not, no. And those are documented. You'll see them. They're all on what we call the box runner. You have the ability to execute scripts, execute templates, execute snippets of code, right? So those will go through that lifecycle. Well, try it out. Give us some feedback. Like I said, we're still in our infancy, and we would love to see how this progresses. We really did this for all our customers and all our applications. So we know it's working, so we would love great feedback from you guys, or collaborations.
If you have more questions, our booth is all the way down to the left when you walk out.
Yes, or you can go to boxlang.io.